Hi everyone, and welcome back to basically the last week of the course in terms of content. For this last topic, it's going to be maybe at a bit higher of a level. Usually you'd cover this topic in maybe a third or fourth year CS course. So given that, um, you'll be, some of the ideas will be helping you in your assignment 4, but in terms of being tested on it, the types of materials that I'll ask you from this section will be very surface level. So things like just knowing the difference between supervised and unsupervised learning, which I'll talk about. Just being able to sort of distinguish between those two. That's really all I'm going to be able to ask you from this. Maybe a fun question like what you enjoyed about your assignment. I don't know, but when I write the exam, um, I'm not going to expect you to, for example, know details about support vector machines or anything like that. So, yeah, going through this lesson or this module, it's really more to give you an intro to some machine learning ideas and a very bird's eye view at that, because we're not really getting into the implementation. So yeah, I want to give you an intro to machine learning, and the other thing I want to do is I want to help a bit with your assignment 4 if you're lost and not sure how to sort of approach it. And basically how the rest of the semester is going to go, maybe in the next couple of days, I will release another module, and that'll have to do with the exam, with proctor track and things like this. Next week will be an exam review. So I'll do an exam review that week, and you'll also have some time to work on your assignment, which will be due the 4th. The week after that is a shorter week. I think classes end, or the semester content ends on the 9th. So there's no new module this week. We might do some more review, I'm not sure. But just know that this is going to be the last topic for the course. And you also don't have to know most of it. You really just have to have a general idea of some of the bigger concepts like supervised learning and unsupervised learning. And more specifically, I'm saying basically, can you distinguish between the two? Maybe in the short answer or some sort of multiple choice. So, okay, let's get into the video. I started the module with just some examples, some more examples of machine learning. I think I have a few on the assignment page. But if you can't tell, I like machine learning a lot, and I'm trying to maybe get you a bit interested because I think it's exciting. And if you really don't care, you definitely don't have to click the videos. This is just me trying to show you a bunch of different things that I find pretty cool about machine learning. Like there's so many different, for example, applications of this. So one thing here is this person is teaching an AI to play a video game, and this is using machine learning techniques. Another one, these people are creating a sort of like a medical device, but they're not making a medical device. They're using your smartphone, the camera, and they're actually, you can take your camera to a lesion, a skin lesion, and it'll tell you whether or not it might be cancerous. But watch the video for more details. I might be missing something there. And the last one is just about Amazon Alexa, and that's also using tons of different machine learning approaches and tools. And there's lots more, but just to show you sort of some things that machine learning can do. before we get into the topic. So what is the topic? The topic again for this module is going to be machine learning. And once again, just have sort of a basic understanding of some of the ideas like supervised learning and unsupervised learning. You don't need to you're not going to be expected to know, for example, how support vector machines work or how k-means works, and I'm not really explaining them very well in these couple of videos. So of course I wouldn't expect you to be able to then explain them back to me, right? Because we're really just looking at those ideas from a surface level. So enough talking, let's get into the lesson. We're going to be covering two types of machine learning: supervised learning and unsupervised learning. There are more, but these are what we're covering. And in general, what's a general definition, which again, you don't have to memorize this or anything. What's a general definition of machine learning? It's basically a set of algorithms which have to do with teaching a machine. What do I mean by teaching a machine? I mean having a machine learn to do something. Okay, that could be seeing other cars on the road, or being able to classify odors using an electronic nose, or whatever. You know, there's tons of applications which I've shown and way more that I haven't shown. What are we going to be using, and what should you probably use for your assignment? I would say go into scikit-learn, take a look at this link, and you can make a classifier in maybe 4 or 5 lines just using scikit-learn. So for the assignment, I'm not expecting you to create your classifier from the ground up. You're really just going to be able to use something that was already made, and you're just manipulating your data, feeding it in, and comparing your two classifiers. And that's the idea behind assignment 4. And when I say classifier, I'm talking more about machine learning, or I'm talking more about supervised learning versus unsupervised learning, which you'll see in this video and in the next couple of videos. So supervised learning, let's get into this. This is where, when I talk about building a classifier in assignment 4, this is the category under which you would want to pick your classifier. So techniques include things like neural networks, support vector machines, decision trees, and things like this. These are all methods where you can have them set as, or you can have them working as classifiers. You can use them to classify things. Okay, so how is supervised learning working from a bird's eye view? What's the general idea without getting into the details? Because the details, there's a lot in here, right? So if I say here's a duck, you might see this image and think, okay, that's easy enough. This is a cat, that's easy enough. But how does a computer actually know that this is a duck? How would a computer see this? And that's a big question. That's even still, in some senses, a research topic. But there are definitely accepted ways to represent this for a computer. One way, for example, might be take the top left pixel and the other pixels, maybe like start from the top left pixel, move from left to right. Let's say this is 500 by 500 pixels, or however many pixels there are. Each pixel will have some RGB value, and if you take them and put them into an array, then maybe you have some representation of this image. And we won't go into details about that, but just to give you an idea of that the computer is not seeing things the same way that you are. So things are going to be a lot more complicated when you're feeding these into your classifier, for example. But let's back up a bit. Compare these. Let's get into how we would compare these and how we would come up with a decision. So, supervised learning. The idea is, I give you some images and I tell you what they are. So I give you this image here, I say this is a duck. I give you this image here, I tell you this is a cat, and then based off of what you've learned, I want you to tell me what this is. Okay, again, easy enough for you to do, and you already know what these things are. But for a computer, a lot more difficult. So why is it called supervised learning, and how is it going to be different from unsupervised learning? As I'll talk about in the unsupervised learning approach, the difference is with supervised learning we have labels for our training. Okay, so when we're training our machine, when we're trying to get our machine to learn, we are providing each sample with a label, is what we call this. So this is a label, duck is the label for this image, cat is the label for this image, and based off of the training, I'll do some sort of testing and I'll say, okay, here's this new image you haven't seen. What is the class label associated with this? Now with unsupervised learning, there are no labels that are provided. Even if you have a data set with labels, you don't put the labels into your system. You just say, here's a bunch of data, try to maybe cluster it, for example. Notice the word clustering versus classifying. So clustering is more of a unsupervised learning task. Classification, like assignment 4, classification falls under supervised learning. So when you're doing your assignment, when you're doing your picking your machine learning approaches, you're going to ideally want to pick supervised learning approaches. Okay, so let's get into some terminology with supervised learning. What is this technique that we're doing that is very common in supervised learning? It's called classification. Okay, so it's the idea of taking samples and putting them into or assigning them to a class label, each of them to a class label. Based off of what? Based off of their attributes. So the attributes for this image, like I was saying, might be all of the pixels in order for maybe the top row to the second row to the third row. All of those pixels, each of them might be one attribute, for example. But for a simpler data set, we might have 3 attributes, and those could just be certain floats. And we want to train our system with these attributes, give it the class label, give it another sample, give it another class label, and so on. And we probably want to do this hundreds of times to get it to learn. And then once it's able to find a relationship between the inputs and the outputs, inputs being the attributes, output being the class label, then we can start giving it some new samples it hasn't seen before. Right? And what do I mean by samples? Again, this is more terminology. By samples, I mean this set of attributes. So this here, this first row, not including the class label, that's an unlabeled sample. Okay? This first row, including the class label, is a labeled sample. So going back up to here, what we're doing with these systems is we are training them and testing them. So we train on the majority of the data set, and when we train, we also provide the labels. So we might feed this in as our training input and output, input being the attributes, output being the classes. And then when we test, we'll feed some new samples that this system hasn't seen before, and we won't provide the class labels. And what we're going to want to do is see, can our system predict these class labels? This word's important, generalize. So why don't we want to, you might think, for example, why don't we just feed these samples in to our system, give it the labels, and then test it on the same inputs and see if it can correctly predict those labels. The problem with that is that maybe, yes, it would be really good for these samples, it'd be really good for these 4 samples at predicting the outputs. But then, if we do that too much, then once we give it something different, it'll have a tough time predicting the output correctly. And what I'm saying is it'll have a tough time generalizing. So what we ideally want to do is feed a variety of different inputs and train our system on a variety of different inputs and classes. And then when we test, we want to give it something new so that we can actually determine whether or not it's able to generalize the relationship between the inputs and the outputs. Okay, so getting into the terminology again, let's review some of the things I already did mention, but just to reiterate, attributes. These are basically, another word you might see for that is features. So these are basically characteristics of each of the samples. When I say attribute 1, attribute 2, attribute 3, this might correspond to color, weight, height, something like that, right? Let's say you're dealing with your iris data set. That's a very popular data set. There are certain attributes for each of the, I don't really remember, I think these were flowers, and there's petal length and things like that. So one attribute might be petal length, and it could be 4 centimeters for this sample and 25 centimeters for this sample. But the attributes are basically some characteristics with each of the samples. And again, what is a sample? A sample is, in this case, one row of the data set. Now don't take that so literally. So if the data set was represented in a different way, where you had the attributes labels are on the columns or are on the rows here, not that I've really seen that. The point is that for each attribute or for each sample there are certain attributes, and these 3 values here are basically the sample. Okay, so for sample 1 we have 0.089, 1.211, 2.959. That's basically one sample. If we want to call it a labeled sample, a sample with its label, then we would say the sample also includes the class label. So in this case, class 1. So our sample is these 3 cells making up the row, and then also the class label. That would be a labeled sample. If it was unlabeled, it would only include these 3 values. Okay, so some of these things I've talked about. Maybe I'll talk about input and output. Okay, so when I say input, and in your assignment when I'm referring to input, I'm really just referring to unlabeled samples. And when I'm referring to output, I'm talking about the labels. Okay, so the input, see what this looks like. This is just the samples without any class labels. And remember, these are the same samples as these. The labels were 1, 2, 1, 2. But we're calling this our input, and we're calling this our output. And when we train our system, we'll feed each of these separately. I mean, you could have this as a single thing and just compartmentalize these and feed them in like that, but one way I like to do it is just have my input and my output, and I feed those into my classifier. But you can do it however you want. This is just one way. So when we train, we feed our input and our output, and we might call them our training input and our training output. When we test our machine, we feed it a new set of input data, and we want it to come up with the output. So in this case, the answers here, or the class labels, are going to be 1 and 2 again, and ideally our classifier will spit out 1 and 2 when we provide these 2 samples. Again, why is it 2 samples? Because each sample is 3 attributes. So this is one sample here, this row, so 0.94, 1.59, 2.85, this is one sample, and the second sample is this row here. And again, these are unlabeled. Okay, and what's this big thing here? I put this in here because I just wanted to show you what one visualization could look like for your assignment. So you can use sklearn to generate this, or whatever else. So this is a confusion matrix, and what's the idea here? The idea is that you have your predicted labels on this axis and your true labels on this axis. Labels, remember, these are the classes. So this is not having to do with our data set. This is just a random confusion matrix. And in this matrix there are, or in this system, it looks like there are 5 classes, 0, 1, 2, 3, 4. And this looks like a pretty good classifier in this case. Notice that there are, in the brackets here, these are the numbers of guesses that were correct, basically. And how do you read this? You read this as, for here, for example, for this cell, we're saying that the system made a prediction that a certain sample was in class 1, when in reality, since we have the samples, or we have the labels, the true answer for the class, or the true answer for the sample was class 4. Okay, so we predicted class 1, the answer was class 4. We got it wrong one time, this one time. Let's look at another row and column. So here we predicted, maybe let's look here. In this case, we predicted row 3, or our machine learning classifier, our system, whatever we used, predicted class 3, and the true label, the answer was class 0. Okay, and this happened 2 times. So there were 2 samples that were fed during testing. By the way, this confusion matrix is what you're going to make when you're testing, not when you're training. Because when you're training, it has all the answers. It doesn't need to guess the labels. It's only guessing the labels. I mean, it is guessing the labels during training, but you only need to quantify this visually for testing, because this is really where it counts. This is where you're seeing how good your classifier is, right? So let's look at a couple more entries just to get some clarity on how this is working. So this right here, the 240, what this corresponds to is that the system predicted class 1 and the true class was class 1. So 240 times it correctly predicted class 1. And let's pick another one. Here, for example, there is one instance, so one of the samples in your test set where the prediction was class 3 and the true label was class 2. Okay, so hopefully you have a general understanding of how this is working. And to make it, you can just you can figure out if there was a correct label or an incorrect label based on the fact that you know all the labels and you can get all of the guesses in a list, for example. So when you're creating your classifier, there are methods to get your predicted output. So maybe your predicted output could be something like this: 1, 2, 1, 3, 4, 1, 2. So maybe these are some predictions, and this is for 1, 2, 3, 4, 5, 6, 7 samples in a test set. So let's say these are your predictions. You would also already have the true class labels. So maybe these are your true class labels, and then you can make your confusion matrix from here because you have all of the guesses from your machine and you also have all of the correct answers, so you can make up a matrix like this. Okay, so let's go on. Well, maybe we'll save that for the next video. We'll go on to support vector machines. For this video, I did also want to do a bit of coding and show you how to make your data set, or how to organize your data set and get it into input and output and things like this. So I have a data set here, just a toy data set, and by toy data set I mean one which I just made to show some examples. I would say don't use this, don't try and just copy this from the screen and say that that's your data set, because it's really just the numbers 0, 1, 2, 1, 2, 3 with some randomness added to them. There's no meaning to these. This isn't a real data set. This is just to show you how to do some examples. Okay, so this thing that I made, this data set that I made, has 3 attributes and 2 class labels. I have 39 samples, and let's see how we might want to feed this in to our system, or organize this and get it ready for our system. So first of all, we're going to need to do some imports. So we can import pandas. We can also import matplotlib. And we're just going to use these to deal with a CSV file and then also do some plotting. So what was the name of my data frame? Let's go to that. So my data frame, it's toy dataset5.csv. Toy dataset5.csv. Okay, and ideally you're going to want to make sure that this is in the same folder as wherever you're running your PyCharm script. So in this case, it's in PyCharm projects CS2120, and the name of the file is week11.py. So I'd want to make sure that this CSV file is also in PyCharm projects CS2120. You could have it in a different folder. You would just have to refer to it here, whatever the folder name is. Okay. So let's try plotting some of this data just to see what we're dealing with. So we could just say A, well maybe we'll call it X. X equals the X component and Y is the Y component. And we'll just plot 2 dimensions or 2 attributes of the data just to see what it looks like. The name of the column here is attr1. So we're taking that column and we're just going to convert it to a list. And we're going to do the same with column 2. And then to color our data by class, we can just pull up these class labels. We can put these into a list. So how would this work? So for this first x coordinate and this first y coordinate, we have a class 1, so it'll color that point red. For these 2, x and y, we'll color this blue, and then red and blue and red and blue, or whatever colors it chooses. Why am I not picking the third attribute? I could plot in 3D, but to keep it simple, I'm just going to plot 2 of them, and we're going to see if we see a pattern. So XY color, we'll say our color is going to be our class labels. Maybe we'll just say class labels equals our data frame, the class column, and we're going to convert it to a list. And then now we can just do a scatter plot of our X, our Y, and C is how we choose our colors. So we say C equals whatever list we're dealing with, which corresponds to all of the colors. So we have class labels is going to say it's going to be a list which is 1, 2, 1, 2, 1, and 2, and that's going to correspond to these XY points. So what it'll do is it'll color the XY point corresponding to class 1 a certain color, and all those corresponding to a different class label a different color. And you'll see that in a second. And maybe I'll take this out for now just to plot the data. So typo right away. I should have typed read CSV, read underscore CSV, to read my CSV file. Let's go ahead and run this. And another thing I forgot, I'm already forgetting a couple things. We need to type plt.show in order to have our graph show up. So let's do that and run the code. Oops. It has to go below our scatter plot. Okay, let's try that again. Okay, so here is our scatter plot, and you can see before I even color them that this was a data set that I just made. You can see this is one class right here, and this is another class. And when I color them, let's do that. C equals class labels. The colors are going to be corresponding to whatever class they're in. So these are class 1 and this is class 2. Okay, so that's just a way to see how your data looks at first. And we can comment this out. Because now what I really want to do is show you how to get your data to look like this with your input and your output. Okay, so maybe for training you want to feed it some size, some sample size of input, and also include your corresponding labels. So let's do that. Let's figure out our length of our training set. And again, we have a training set which we're feeding this into our system, to our classifier. We're also providing, so what we're providing in our training set is our inputs and our outputs, or our samples and the corresponding labels. Okay, so we're providing that to our system when we're training it, and that's our training set. And in that step, in the training step, the system is learning to associate the attribute values to a certain class. Once we've trained our system, then we test, and what we do is we have a test set, and that will have samples which are not labeled, and we want to predict the output classes. Okay, so let's create those sets. We can say train length is, let's just take the length of the data frame. We'll take 80% of the data frame. That's a pretty reasonable training amount. Usually you'd also see something like validation for neural networks, for example. But we're not going to cover that here. We're just going to do training and testing. So we'll convert this to an integer, and that'll just be some number, which is how many training samples we have. Okay, we can print it just to check. And we can also get our test length, which is the size of our test set. Okay, so length of the data frame, and we'll subtract the train length to basically say whatever's left, we'll use that as our test set. Okay, and let's run this just to check. Okay, so looks like we have 32 training and 8 test samples. And I think I said we had 39 samples. So to be safe, let's just take off one of the test samples. Okay. All right. So in this case, we're going to have 32 training samples and 7 test samples. Okay, so we're going to take the first 32 samples with the class labels. Those will be our training set. The next 7 samples without the labels will be the test set, and then we'll use the labels to see if the system correctly predicted the classes. Okay, so these are just the sizes, and now what we want to do is actually make these sets, these train and test sets. So we can say input train. This is our input for the training set, and we can use lots of things, but maybe one way we can go is to say data frame at location, integer location. That's what the ILOC means. We're specifying an integer location with which to pull our data from. So we're saying our input train is our data frame at these integer locations. So we're going to go from 0 to train length. So we're going to pick, this is corresponding to the rows, and after this is corresponding to the columns. So for the rows, we're going to go from row 0 to row 32. Okay, and we're going to go from column 0 to column 3. Why column 3? Considering this is column 0, 1, 2, when we slice the 3, we're not actually going to the 3. Okay, we're stopping. Remember, with slicing, we go 0, 1, 2 when we write it like that. So 0 to 3 is actually going to be 0, 1, and 2. And 0 to train length is actually going to be 0 to 31, not 32. So we can print this just to see what it looks like. And then output train. So these are the class labels. So remember, input was our data set with all of the attributes without the class labels, and our output is the class labels. So since we want these class labels, we will say df.iloc, and again we're going to take the same row values, but instead of column 0 to 3, we can do 3 to 4, which will just be column 3. And we'll print it just to see what we're working with. So let's check this out. Okay, so you'll see input train is here, right? These are the indexes, or the indices, and here's our first training sample. Okay, so the idea is you feed this sample in, and we give it the class label, which is label 1, and that's corresponding to our output. So this is our input, and then this is our output. And this is corresponding to training. Okay, we also need test data. So same idea. Input test df.iloc, and which rows are we looking at here? Well, we're going to start from the train length row. So start from row 32, and we're going to go seven more rows down. So we'll say train length plus test length. So this would be 32 to 32 plus 7. Okay, so we're doing 7 rows of testing, and the columns are going to be, again, from 0 to 3 for the input. So this is input test, so the input is these columns here, 0, 1, and 2. For output test, df.iloc, again, since this is test, we're starting from row 32. or whichever row, row 32 or whichever row it said previously, the end of the train length, or after the training set, whatever row that is. So from train length to train length plus test length. And since this is output, maybe I'll zoom out a bit. Since this is output test, we're going to be going from column 3 to 4, or just column 3 is another way of saying that. So we're looking at the class labels. So output is the labels, input is the samples with their attributes only. Test is the remaining rows, and train is the first however many rows. I think we said 32. So we have our train and test splits, and this is good because in the next video we'll be using these to train a classifier, and the classifier we'll be looking at is the support vector machine. So we'll see you in the next video.